To use the darknet executable file to train a YOLO version 3 convolutional neural network based on a custom dataset, I will eventually execute a form of the command exclamation point, reference to the darknet binary, detector, train, reference to the object.data configuration file, a reference to a YOLOv3-object configuration file, a reference to the darknet 53.conv.74 base set of weights, and a don't show flag. Before running my darknet executable file, I want to prepare data files, like object.data. Each data file will provide darknet with information on the number of classes of objects I have identified in images in my training dataset, the location of a text file listing of paths to images in my training dataset, the location of a text file listing of paths to images in my validation dataset, the location of a text file listing of the names of classes of objects, and the location of a folder in which to save a weights file that the darknet binary will use to initialize the values in each cell in each filter in the YOLO version 3 convolutional neural network. Joseph Chet Redmond is the creator of the original darknet deep learning framework. YOLOv3 offers an optimized version of Redmond's framework. Instructions on how to use Redmond's and YOLOv3's frameworks are available on Redmond's YOLO version 3 webpage. To navigate to Redmond's YOLOv3 webpage, open a new tab in Chrome, type https://pjready.com, press enter, left-click darknet, scroll down a little bit, and left-click YOLO real-time object detection. The data file corresponding to Joseph Chet Redmond's second presented command to train a YOLO version 3 convolutional neural network based on the COCO dataset, which is reference to the darknet binary detector, train, and a reference to the COCO.data file. The data file here, obviously, is COCO.data. One version of COCO.data is located on our virtual machine in root content darknet, the configuration folder, COCO.data. Execute the command exclamation point head 6 path to COCO.data to take a look at the first 6 lines of COCO.data. I want to revise COCO.data to reference a text file listing on my virtual machine of paths to training images, a text file listing on my virtual machine of paths to validation images, a text file listing on my virtual machine of the names of classes of objects, and a folder on my virtual machine in which to save a weights file. I want COCO.data to look like this. To get COCO.data to reference files in a folder on my virtual machine, I execute the command !stream editor in place substitute for the path to the text file listing of paths to training images the assignment of the desired path to the text file listing of paths to COCO training images. And a reference to COCO.data where to do the substitution. Similarly, stream editor in place, substitute for assignment of the path to a text file listing of validation images, substitute with my desired assignment of path to text file listing of validation images. And a reference to COCO.data, again, in which to do the substitution. And finally, stream editor in place, substitute for assignment of the location of the backup folder in which to save weights files, substitute with my desired assignment of the location of the backup folder in which to save weights files. Do this substitution also in COCO.data. Just checking very quickly. Looks all right. Let's try it out. It seems to have worked. I will check that my version of COCO.data references files and a folder on my virtual machine by executing the command !head 6 path to COCO.data. Here we have the number of classes defined as 80, the desired path to our text file listing of paths to training images, the desired assignment of our path to our text file listing of paths to validation images, a good path to the COCO.names file listing all of the text names for each of these 80 classes, and a good assignment of the location of a backup folder in which to save weights files generated by training. All right. The data file corresponding to locating objects associated with the Pascal VOC 2007 and 2012 datasets is voc.data. One version of voc.data is located here on our virtual machine in root content darknet, the configuration folder voc.data. Execute the command !head 6 path to voc.data to display the first 6 lines of voc.data. I want to revise voc.data to reference a text file listing on my virtual machine of paths to training images, a text file listing on my virtual machine of paths to validation images, a text file listing on my virtual machine of the names of classes of objects, and a folder on my virtual machine in which to save a weights file. I want voc.data to look like this. To get voc.data to reference files in a folder on my virtual machine, I execute the commands !stream editor in place, substitute for the assignment of the default path to the text file listing of paths to training images, with my desired assignment of the path to a text file listing of paths to training images. Do this substitution in the voc.data file. Similarly, stream editor in place, substitute for the assignment of the path to a text file listing of paths to validation images, with my desired assignment of the path to the text file listing of paths to training images, validation images, excuse me. And do this substitution in voc.data. Similarly, stream editor in place, substitute for the default assignment of the location of the backup folder in which to save generated weights files, with my desired assignment of the location of the backup folder in which to save weights files. Do this substitution in voc.data. Taking a quick look, seems to be okay. Let's try it. Seems to have worked. I will check that my version of voc.data references files in a folder on my virtual machine by executing the command !head 6 path to voc.data. Okay, here we have the number of classes associated with the Pascal VOC 2007 and 2012 datasets set to be equal to 20. Here is my desired path relative to root content darknet of the text file listing of paths to training images. Here is the assignment of the path to our text file listing of paths to validation images. Here's a good path for the names files that includes all of the text names for each of these 20 classes. And here is the assignment of the location of the backup folder in which to save weights files during training. Cleaning up, I will remove my reference to what I wanted voc.data to look like. I will also remove this reference to the call to the darknet binary that we will eventually use to train a custom dataset. And I will remove this cell that describes what I wanted COCO.data to look like. To create a data file corresponding to locating objects associated with my own dataset of 100 images of oak leaves from various species in Quercus, the genus of oak trees. On my Windows 10 PC, I minimize my Jupyter notebook, press and hold Shift, right-click my desktop, left-click Open PowerShell window here, reposition and resize my PowerShell window, right Notepad, press Enter, resize, reposition, and resize my Notepad window, left-click File, left-click Save As, delete the suggested file name, press the down-pointing chevron, right of Save as Type, left-click All Files, move this up, enter object.data as the file name, and left-click Save. To fill in object.data, I write classes equals 1, path to the text file listing of paths to training images in my Quarkus dataset is Quarkus dataset slash train.txt. The path to the text file listing of paths to validation images associated with my Quarkus dataset is validate.txt. The path to my names file with the string names for each of my 1 classes is root content darknet data object.names. And I want weights files to be saved into the root content darknet backup folder. I will save object.data by left-clicking File and left-clicking Save. I will return now to view our Jupyter Notebook YOLO version 3 training. At this point, I'm going to make sure my files outline is minimized. To copy object.data from my desktop on my Windows 10 PC into the file root content darknet configuration folder in the file object.data, I navigate to my Google Drive's darknet folder, right-click within the window to all the folders and files in my darknet folder, left-click Upload Files, left-click Object.data, and left-click Open. I then navigate back to my Jupyter Notebook and navigate to the root content directory by executing the command $cd. While in the root content directory, I mount my Google Drive as a virtual drive accessible by my virtual machine by executing the command from google.colab import drive. Drive.mount to content/drive. I left-click this URL, left-click my name, scroll down a little bit, left-click Allow, left-click the Copy button, navigate back to my Jupyter Notebook, right-click in this text box under enter your authorization code, left click paste, press enter. Left click refresh and close the authentication window. Here is my Google Drive, accessible as a folder/drive on my virtual machine. I'm still in the root content directory. I copy object.data from my Google Drive's darknet folder to root content darknet, the configuration folder, and the object.data file by executing the command !copy from drive/my \escape character space drive/darknet/object.data to root content darknet, the configuration folder, object.data. I then navigate back to the root content darknet directory by executing the command $cd darknet. Next up, preparing configuration files.